Section 9.4 video. Hey guys, finally something easy. Section 9.4 is just a recap of all the different kinds of graphs and functions that we've talked about along the way. So for all intent and purposes, it's a matching section. So just name them. So in the box here is all your choices, all the different kinds of functions that we've talked about this year. And down below, let me scroll down and give you a quick peek, are 9 different graphs. Now, unfortunately, I'm going to have to scroll back and forth with you, but you can back up and check up the video if you need to. So I'm just going to start with the ones I think are easiest. And I think you guys hopefully would agree with me that the greatest integer function is the easiest because it's also called the step function, and all you're looking for is a set of steps. I don't see a set of steps. I don't see a set of steps. Looky here. I see a set of steps. So I forgot which one it is already. So that's D. So right here, this guy, D. So matching that up, greatest integer function or step function. I think the next one that's easiest to do would probably be absolute value. And absolute value has a V in it, therefore it looks like a V shape. So let's take a peek. Hopefully you can tell this third graph over is actually curved down at the bottom. It's a U shape. So I'm still looking for a V. I'm still looking for a V. I found a V. So that was E to match it up. So right here, this guy is a V-shaped graph or absolute value. The third one I think is the easiest to pick out would be piecewise. So basically, we talked about this. We said a piecewise function is just a bunch of pieces. So these first 3 graphs are all continuous. They're not broken up. This one clear over here on the right, and that's a little bit interesting. It's got kind of some pieces, but take a look at this guy clear down in the bottom. He's got a whole bunch of pieces, bottom right corner. And again, I forgot, it's letter I. So this guy is a piecewise function. Okay, back up to the box we go. Quadratic. Notice the word quadratic has a U in it, and we did those not too long ago. It is a U-shaped graph, and if you can tell, I hope you can tell down here at the bottom, this is supposed to be curved. It's not the best drawing I've ever done, but a curved or U-shaped graph is quadratic. So that guy's F. And this one we did recently, the rational or fraction. So I suppose the best way to remember this is the word fraction. And I know fractions cause you guys grief. So I guess what you could say to yourself is this. If a fraction is the hardest thing up there, that's the name that causes you the most grief, which one of these graphs caused you the most grief? Well, none of these look particularly difficult with the possible exception of, I would say, these two right here. But we already said this guy down at the bottom is piecewise. So this guy right here was the one that had an asymptote, which had a fraction in it. And once again, I forgot what letter. So this guy is H, rational or fraction. Now, we do have to clarify a little bit here on these last couple. Square root. Well, let's get rid of square root. So square root was the guy that's, if you think about it, square root and x squared sort of have something to do with one another. So if x squared is that guy, you can think of this in terms of the square root would be kind of half of that. So right over here was the square root graph. This is the one that made that arc that's sort of half of a U shape. All right, so that brings us to these 3 guys right here. And I've left them for last for this reason. These guys are all linear. And then mathematicians like naming stuff, so they split up the definitions for specific kinds of linear. So linear means line, straight line. So the 3 that are left, let's take a look. That's this guy right here, this guy right here, and this guy right here. All make straight lines. So which one is which? Well, we did talk about constant already this year. And constant is simply a horizontal line. So specifically, it's not tilted, it's not straight up and down, it's not no slope line. So constant was the horizontal one. So that's this guy. So we did talk about that already this year. So the other 2 are new. I'm just going to go ahead and tell you direct variation is any angled or tilted line except the one I'm going to leave for last. So direct variation. So could be this guy right here, right? But I'm going to tell you that guy's identity, and I'll show you why here in a second. Well, the only other one that's a straight line is that guy. So he's tilted. He's diagonal. That's direct variation. So here's what's special about this last line, and it's why they gave him a special name. What's that set of coordinates right there? That's 1, 1. What's this set of coordinates right there? 2, comma 2, 3, comma 3. What's this set of coordinates down here? -1, -1, -2, -2. So the y's and the x's are the same every single time. So that line has a specific equation that goes with it, which is y equals x. And if you remember, when we did the inverse graphs, that was the symmetrical line for the inverse graph. So it's special, and that's why they gave it a special name. It's called the identity. And that covers all the graphs. So real quick recap for you before I move down to the equations. Square root graph, kind of half of a u on its side. Identity is that guy that goes right up that 45-degree angle. And we did use him earlier this year as a symmetry line. Quadratic. So quadratic over here is a U-shaped graph. Direct variation will be anything that's a straight line that's not the other two. This one's easy. Absolute V for value. This guy we did recently, he's the crazy looking hard graph to do. So fractions are crazy and hard. So H, or rational fraction, or fraction function for that guy. Constant we did earlier this year. So constant, horizontal lines. This is the easiest one of all, right? Step, looks like steps. And a bunch of different pieces. So that's the one that was piecewise. All right, so we're going to have you match those on a quiz. Oh, got an ad in there by accident. Sorry about that. So we're going to scroll down here and take a look at the equations, which I think, in all honesty, are even easier to match. All right, I can squeeze all those on there. All right, so what do we got? Well, constant. Well, let's start with the easiest ones again. Let's start with absolute value. Absolute value. Do you see an absolute value symbol anywhere on here? Yep. No brainer. E. Square root graph. I'll grab that one next. Square root graph. This guy has a square root in it over here on the left side. So that must be a square root function. Let's see if we can find anything else that's really easy. Piecewise. Well, if you're going to get several pieces to a graph, then you're going to have several pieces to the equation. So this guy right here is the only one that has more than one part to it. So you get 2 parts of a graph. A fraction function. All right, now be careful, right? There's 2 problems on here that have fractions, but only one of them has the variable on the bottom. So that's what we're talking about as far as the variables on the bottom. Here's a variable on the bottom, and this is obviously a fraction. So that is H. How about quadratic? I hope you guys remember quadratic equations had a squared in them. And here's the guy that has a squared in them right there. So that's F. So constant means it's got to be the same number over and over again. So if you remember, f of x means the same thing as y. So if I were to rewrite that one as y equals 8, it's saying 8, y is 8 all the time. So he is constantly 8. And then that leaves a couple here. So we've got the greatest integer or step function. And so hopefully you notice this guy clear down here on the bottom has a pair of bracket symbols. And the other way that they did this, sometimes you will see them written with a double bracket line like that. Sorry, that's terrible. But any brackets are the greatest integer functions. So that was D to match him up. So y equals mx plus b is, for all intent and purposes, what direct variation is. So this one down here in the bottom right corner is y equals mx plus b. And the identity problem specifically has an equation that goes with it. And it's the only line that goes in that 45-degree angle up through the middle of the drawing where all the x's and the y's are the same. So the identity literally is y equals x every time. So this equation, the one and only equation that represents identity. There you go. They're all matched up. So I hope that's good news. Section 9.4 is just a matter of matching the names to the graphs or matching the names to the equations as we've done this year. All right, guys. Thanks for watching.